Okay, good morning class. So today we're looking at probability. We are looking at the two-way contingency table. Okay. For those of you who want the full lesson, you'll find in the description box below. Okay. But we are basically told that two-way tables display the number of outcomes of each event. The various probabilities can be calculated from the information in the table. Each example we will look at the data rather than the probability experience. Okay, so we're looking at example 1, and example 1 is on page 415. Okay. Example 1 on page 415. So here we are told that 100 people were asked, so you see 100, that's your total. Always be your total. Given 100 people were asked which season they preferred, and the information were entered into the accompanying two-way table. Okay. So we had female, male, and a total of 50 males and 50 females. And like summer, there's a total males and females who like summer 69, likes winter, the total of males and females who likes winter is 31, and the totals comes to 100 both ways. Okay. The first question says, determine the following. A. The probability of the person selected at random is female. So what's the probability of female being selected? Sorry? How many females are there? 50. How many people are there in total? 100. So it's going to be 50 over 100, which is? Or 50% or 0.5. B. The probability of male and is your intersection. Not so. So it must be of both categories. Male and likes winter. Male and likes winter is how much? 11. Yes. 11 over 100. Okay. C. The probability. We're selecting a person at random. It's female. The person is female. And like summer. So female and like summer. It's going to be 30. Can you see where they can intersect? It's going to be 30 over 100, which is 3 over 10. Any confusion there? Okay, normally we write it in decimal if you like. This is going to be 0.3 or 0.11 or 0.5. Or in percentage, it doesn't really matter. However, if that is your probability, please simplify. Okay? Otherwise, of course, you lose some marking. Now, determining whether events are independent or dependent. Now, what is the identity for independent events? The probability of A intersection B is equal to the probability of A times the probability of B. Okay, very important for this two-way contingency table. This question is normally associated with this two-way contingency table. Okay? So, determine whether the events are dependent or independent. If A and B are independent events, that's the formula. Conversely, if A and B, the probability of A and B is equal to the probability of A times the probability of B, then A and B are independent events. So if the formula applies, then the events are independent. Okay? We can use this fact to test whether an event depends on another event. So now we're looking at example 2. Example 2 is on page. Example 2 is on page. Sorry? 416. 416. Okay. So 90 people. So 90, we check, yes, that's in order. Okay? 90 people were interviewed on whether they preferred sweet foods or savory foods. And the results were recorded in a two-way table. You guys know what savory and sweet, no? Cake and the contrary samosas is. Alright. Or biscuit, that's savory biscuits or whatever. Okay. So determine the following. A. The probability of being male. So what's the probability of it being male? 55. So probability of male is 55 over 90. But 55 over 90 55 over 90, that gives you 18 over 11. 11 over 18, ne? Sorry. 18 over, 11 over 18. B. Probability of male and like savory. So male and like savory. It's going to be 33 out of 90. Not so, which is 11 out of 30. No? Okay. C. So this actually C's answer, no? B. The probability of savory. Probability of savory. 54. Probability of savory is 54 over 90. So 54 over 90, 3 over 5. You all okay with that? Then C was the probability of male intersection savory. D. Do you either want you to work out the probability of male times the probability of savory? Am I moving too fast? No, you guys understand, okay? The probability of male is 55 over 90 or 18 over 11 over 18 times probability of savory 3 over 5, which gives us an answer 11 over 18 times the last answer calculated 11 over 30. Is that correct? It's 11 over E. And this is now different to the previous one. Does the data collected from the survey show that food preferences are independent of gender? So, if the food preference was independent, then I'm going to prove the formula for the probability of male intersection savory is equal to the probability of male times the probability of savory. This was the formula. A intersection B is equal to the probability of A times the probability of B. You guys understand? No? Now, since we have done calculations dealing with male and savory, that is why I'm using this one in particular. Okay? So if male and savory is independent, female and savory will also be independent, so will male sweet be independent, and so will female sweet also be independent. So when we do the calculation for independent events, you just have to do it for one of it. If one of it is not dependent, the rest will be not dependent. If the one is dependent, the rest will be dependent. Does it make sense? So, we don't start off with the formula as it's lying. We're going to prove that. So what do we say? The probability of male intersection savory is equal to, okay, we did the calculation already, no? So we say since, so we state the obvious, since the probability of male intersection savory is equal to the probability of male times the probability of savory, which is equal to 11 over 30. Therefore, the events are independent. Okay. Does it make sense? Alright. This is a very important conclusion to draw. We'll be able to answer. Okay. Any confusion there, people? Okay. Last question, question 3. There are 2 more examples. Okay, so example 3. Then that's the answers linked here. Okay, that's a different part. Okay. This is example 3, and this example 3 is on page 140.
Good afternoon, may I have your attention, please?
416.
Private meeting will be in room 17, now at break. There will be a private meeting in room 17 now at break. And could all students go to the quad for the grade 11's gender-based violence campaign? All students can please go to the quad for the grade 11B's gender-based violence campaign.
Okay, I'm just going to use 2 or 3 minutes of your break here. For those of you who want to leave, you can leave now. Sorry? Campaign. Okay. Okay, so example 3 on page 416. We are told that 80 learners in grade 11 were asked whether they play sport for their school, and the results were recorded in the following 2A table. Okay, so we got the males, females play sport, don't play sport. As a total is 80. So in A, we are asked to calculate the probability of it being female, because it's selected at random. It's going to be 50 out of 80, which is 5 out of 8. B. B says play sport. Play sport is going to be 48. So the probability of play sport is going to give you 48 out of 80. Now 4 goes into both, so it's going to be 3 12. So it's going to be 3 out of 5. So 48 out of 80, 3 out of 5. That's correct. C. C says the probability of female and play sport. The probability of female and play sport is going to be, of course, 21. So it's 21 out of 80. Okay. D. D, we are asked, what's the probability of female times the probability of play sport? The probability of female is 5 out of 8. Probability of playing sport is 3 out of 5. So that gives you 3 out of 8. Okay. Then in E, so that is 0.6. Check here, but everything in order here, so we got 5 out of 8. 5 out of 8. 0.65, that's correct. 48. Okay, that's correct. You want to write this. And then T, 3 out of 8, 0.9. So that's all in order. It's needed to make sure. Otherwise, normally our learners indicate them wrong. E, do you think that the sport preferences are independent of gender? So again, you're going to prove or disprove the fact the probability of A intersection B is equal to the probability of A times the probability of B. So if you look here, the probability of female intersection play sport. So is the probability of female intersection playing sport equal to the probability of female times the probability of playing sport? So the probability of female intersection play sport is 21/80, and the product of the two is 3 out of 8. So is that equal? No. So we say since, just say we state the obvious, since the probability of female intersection sport is not equal to the probability of female times probability of sport. Therefore, the events are independent. Okay. The events are not independent. Sorry. Events are not independent. Okay. Because if they were equal, the events are independent, which means to say they're not depending on each other. Whereas in this case, the events are not independent, or we can say they are dependent on each other. Okay. So with that, you should be able to do exercise 12.6. You can get the full lesson on this in the description box below. Thank you.